Okay. Hi, Anijit. Can you hear me? Anijit Chow.
Yes, sir.
Okay. Okay. Sure, Anijit. You can keep the mic muted. There's some kind of a background noise. Just wanted to verify if you can hear me or not. Let's wait for the others to join as well. We'll start the session in 5 minutes. In the meanwhile, if anyone has any questions also, you can let me know. So again, a brief introduction, guys. We started the classes on Monday, actually. So if you've missed out the previous sessions, nothing to worry about. You can get those directly from YouTube. So all the sessions are being uploaded on the official channel of DurgaSoft. Okay. So you can search for DurgaSoft Cyber Security in YouTube and you would get the sessions which were uploaded yesterday and day before yesterday. Okay. So what we are learning right now is again, as a prerequisite for cyber security, we are going through networking concepts. So in the earlier classes, we discussed about, again, IP addresses, specifically IPv4 addresses. Okay. And then we learned about the range of IPs, the categorization of IPs. Okay. What are, again, there are 5 different categories in the class A, B, C, D, and E. We talked about the ranges of each class in the session yesterday. Today, we're going to talk about what is the necessity for each class. Okay. How each class is relevant for us. So yeah, we'll wait for the others to join as well, and we'll start the session. Okay, guys, so let's get started without any further ado. So as mentioned earlier, we have these 5 classes in the whole IPv4 range. Okay. Now let's talk about the necessity of these classes. So and how they are unique from each other. So each class of IP address is used to determine in the bits different parts of network and host IDs. Okay. So basically dictates how many networks and hosts you could possibly have in each network. Okay. So class A, again, don't worry if that doesn't make sense at the moment. Okay, but I'm going to explain this, elaborate on this in a bit. Okay. So class A has 1 network portion and 3 host portions. Class B has 2 network portions and 2 host portions. Class C has 3 network portions and 1 host portion. Again, Class D and Class E have all network portions itself. There are no host portions in Class D and Class E. But what do I mean by this network and host portions? So to explain that, Let's take the example of class C first, where class C has 3 network portions and only 1 host portion. Now we all know the first private IP in class C starts at the range 192.168.0.0. Now if this is the first IP, next IP would be 0.1, next IP would be 0.2, next IP would be 0.3, next IP 0.4, next IP 0.5. This goes on all the way up to the value 0.255. Now, what I mean by network and host portions is that in class C, the first 3 portions belong to the network portion, and only the last portion belongs to the host portion. So as long as the host portion is changing, it just indicates that each of these is just an individual host in the same network. So the network is 192.168.0.network, and in that 192.168.0.network, this is the first host, the second host, the third host, the fourth host, fifth host. As such, you can connect 255 hosts. But as soon as the network portion changes, let's say when this reaches the maximum number 255, this 0 changes to 1. And when it changes to 1, the network divides over there. So now this is a different group of IPs in a network, and this is a different group. So there are 2 separate networks now. So what it means by the network portion is it gives the identity for the network, and the host portion gives the identity for each host in that network. Okay, so this is the first host, second host, third host, fourth host, fifth host. As such, you can connect 255 hosts in this network. Similarly, in the next network, 192.168.1.network, ignore the 0th IP, that's never used. Okay, this is the first IP, the second IP, the third IP, the fourth IP. As such, you can connect 255 devices in this network. Similarly, in the 2 dot network, 21, 22, 23, 24, as long as it goes up to 255, it's the same network. So each of these is an individual network here, where in each network you're able to communicate a maximum of 255 hosts or 255 devices. So this goes on all the way up to 192.168.2550, 2551, 2552, 2553, up to 255, 255. Okay. So from the first IP till the last IP, this is the 192.168.255 network. Okay, so thereby one important conclusion is, so no matter what network you take in class C, maximum number of devices we can connect in each of that network is 255 IPs, not more than that. So therefore in our home network, when we have a local Wi-Fi connection, in our home network we use a class C network. So that means we can basically connect a maximum of 255 devices to our Wi-Fi router, not more than that. Is that clear? Vivek, Anji, Anijit, and Rohit.
Yeah. So basically, our home router will be having this type of IP addressing.
Exactly. Your router might be getting the first IP 192.168.0.1, and the remaining IPs can be assigned to other devices in your network. So you can connect another 254 devices.
Can you repeat that?
Yeah, again, as mentioned here, we go take this diagram here again.
Yeah,
One,
it will be getting one public IP and then it will be
yeah.
distributing
Ignore the
private
public
IP.
IPs. We're just talking about the private IPs here. So public IP is different again. The public IPs don't have network and host portions. Okay. So what we are
Okay.
referring over here, what we are dealing right now with are the private IPs. So this 192.168.0.1, that's the private IP assigned to your router. Okay. Like that, you can assign another 254 IPs to again in this whole network. Okay, so each device gets an individual IP, and all of them belong to the same network, 192.168.0. This is the first host, the second host, third host, fourth host, fifth host. Like that, you can connect a maximum of 255 devices. Yeah.
Yes.
Okay. So that is what a class C represents. In class C, you can connect a maximum of 255 devices, not more than that. Important point to note. Okay. Now, when you go for the next class, class B. Okay, so class B, remember, has 2 network portions and 2 host portions. So let's take the same logic now. As long as the network portion is same, it belongs to the same network. As long as the host portions are changing, it's irrelevant. They are just different hosts in the same network. Okay, so when we take the class B IP, the first IP in class B private IP range is 172.16.0.0. First 2 portions belong to the network portions. Last 2 portions belong to the host portions. So the first IP is 00, then you have 01, then 02, then 03, 04, 05, 06, goes up to 0255. After 0 to 255, you have 10. The network doesn't change here, guys, because again, both these last two octets belong to the host portions itself. So after 0 to 55, 10 also belongs to the same network. Then you have 11, 12, 13, 14 goes up to 1255, 20, 21, 22, 23 up to 2255. Then 30, 31, 32, 33 up to 3255. Goes on all the way up to 2550, 2551, 2552, 2553 up to 255, 255. Now, once both these octets are filled, what happens then? This 16 changes to 17 now. Now, when 16 is changing to 17, the network portion is different. So whenever there's a change in the network portion, it indicates that it's a change in the network itself. So these IPs belong to one singular network. Again, this is the 172.16 network, and this is the 172.17 network, a completely different entity. Okay, so now if you notice over here from 172.16.00 up to 172.16.255.255, since there are two host portions, you can connect a maximum of 255 into 255 devices in each network. Okay, so which is a much larger number compared to class C. In class C, you could only connect 255 devices, but in class B, it's 255 into 255, which is approximately equal to 65,525. Okay, so in each of these networks, 172.16 network or 172.17 network or 172.18 network or up to 172.31 network, in each of these networks, we can connect a maximum of 255 into 255 IPs. Why two times? Because you have two host portions here. Is that clear? Vivek, Rohit, Shivakumar, and Ajay.
Yeah, so the first host portion will go 2550 to 255, and the second one will be again from the second part till 255 basically. It will be
Yeah,
double
that's right.
basically.
Yeah,
Yeah,
each octet repeats 255 times. Okay, so 00 to 0255, 10 to 1255, 20 to 2255,
224.
30
Yeah,
to
like that.
3255, like that, all the way
Yeah,
2550 to 255, 255. So that is why each octet is repeating 255 times. And since you have two octets, 255 into 255. Okay, is that clear?
yes, clear.
Right. Now, when we come to class A finally, where in class A you have one network portion and three host portions. So class A's first IP starts at 10.0.0.0. Now after 10.0.0.0, next IP 10.0.0.1, 10.0.0.2, 0.0.3, 0.0.4, 5, 6, 7, 8 goes up to 255. Doesn't end there. Then you have 10.1.1, 1.2, 1.3 up to 1.255. This keeps on repeating all the way from 10.0.0.0 to 10.255, 255, 255. Okay, so this is the whole sequence of IPs. Now, as long as the network portion is same, it means it belongs to the same network. As long as the host portions are changing, each host portion represents a different host in the network. Okay, so it is belonging to the same network. So from 10.0.0.0 all the way up to 10.255, 255, 255, this is one singular network itself. Okay, and therefore, since you have one network portion and three host portions, the total number of hosts you can connect in that network is 255 into 255 into 255, a much larger number compared to class B. Okay, so more the host portions, more number of 255 IPs you can connect is what it basically means. You keep multiplying with 255. Okay, so in class C, where you only have one host portion, you can only connect maximum 255 IPs. Therefore, that is used for small networks or home purpose networks. Class B and Class A, which have more number of host portions, can be used for much larger networks, multinational companies or ISP networks. Okay, so that's an important point to note, guys, where you're using each class. Okay, and why there's that distinction factor. So all of this is differing because of the number of host portions each class has. More the number of host portions, more devices you can connect. Okay, so when you come to class D and class E again, they do not have any private IPs. All of them are public IPs itself, and they're used for special purposes, not for your ISP usage, guys. They're used for again different purposes such as research and development, or again broadcasting, telecasting services. Okay, government services. So for government portals, for all such separate bodies, you use the class D and class E public IPs for that. Okay. So that is the difference in each class, guys. Where do you use class A, B, C, D, and E? Okay. So that completes the whole classes part. Now let's go into the next topic, which is subnet mask. So when I ran the command ipconfig yesterday in my command prompt, so when I type ipconfig here, you will notice I got three pieces of information. There was something called as an IPv4 address. Under that, there's something called as subnet mask. And under that, there's something called as a default gateway. We already know what IPv4 address is. This is the IP that is assigned to our system. Okay. Then there's something called a subnet mask. What is the subnet mask? So we humans understand which IP belongs to which class with the network and host portions. But how does a computer know which IP belongs to which class and how many devices can it connect in that network? For that, it needs the subnet mask. So to calculate the subnet mask, what the computer or any other information device does is it assigns the network portion with the value of 1 and it assigns the host portions with the value of 0. Okay. So it basically helps you determine network and host ranges within an IP address. It consists of consecutive ones and zeros, where 1 is assigned to the network portion and 0 is assigned to the host portion. So when you have class A with 1 network portion and 3 host portions, it has all ones in the first octet and all zeros in the 3 octets. So the subnet mask for class A is 255.0.0.0. When you talk about class B, it has 2 network portions and 2 host portions. So all ones in the first 2 portions, all zeros in the last 2 portions. And therefore you have subnet mask as 255.255.0.0. And finally, when you come to class C, it has 3 network portions and 1 host portion. So all ones in the first 3 portions, all zeros in the last portion. Therefore, 255.255.255.0. And if you notice here, the IP which I'm getting here in my command prompt is 192.168.0.5. This is a class C address. And since it is class C, subnet mask is 255.255.255.0. So with this subnet mask, my computer understands, okay, this is a class C address. Therefore, I can only connect to maximum 255 devices in my network, not more than that. So that subnet mask makes the computer understand what is the range of its network. Okay, is that clear, guys? Any questions regarding subnet mask?
It's clear.
Right. Rohit, Shivakumar, Anijit.
Yes, sir.
Right. And under the subnet mask, you have something called default gateway. Now, this is basically just a fancy name given to your Wi-Fi router. Okay, so your router acts as the gateway between your private network and the public network, right? So it's between the intranet and the internet. So when any device in your intranet wants to communicate with the internet, it needs to send the packet to the router. The router acts as a gateway in between, and hence that IP is called default gateway. It is usually assigned the first IP in the network, 192.168.0.1. Important point to note, guys, the reason why it starts from 0.1 is because 0.0 is never used to assign any IP. Okay. So again, let me write it down somewhere. So if you have the network over here, starting from 192.168, 192, one second, guys. Yeah, better. So if you have the network starting from 192.168.0.0, next IP 192.168.0.1, 192.168.0.2, 192.168.0.3. This goes on all the way up to 192.168.0.254, 192.168.0.255, right? So this is your whole network in class C, right? So whenever you have the first IP, 192.168.0.0, this IP is called the network ID. Network ID. And the last IP, 192.168.0.255, is called broadcast ID. Okay, so these IPs are never assigned to any system in a network. Okay, so they are reserved for something called network ID and broadcast ID. Okay, so whenever you have any usable IPs in a network, they will always range from here to here. So from 192.168.0.1 to 0.254. These are the only usable IPs in a network. Okay, is that clear, guys? So this is the usable range of IPs in any class C network, usable IP addresses. Okay, So 00 and 0255 are never used. 00 is called the network ID, 0255 is called the broadcast ID. Okay, and the in-between IPs from 01 to 0254 are the IPs which you can assign to each device in a local network. Important to note. Okay. Coming back to your, the presentation here. So we learned about subnet mask. We know what default gateway is. We know what, again, an IP address is. Let's talk about how do you assign a private IP to your system. Okay. So in our local networks, guys, our Wi-Fi router acts as a DHCP server also. Okay, and it automatically assigns an IP itself. Don't worry what a DHCP server is. We'll talk about that in a bit. First, we'll talk about how to assign an IP manually. Just a second, guys. Give me a minute. I guess I'm getting a call from the institute. Yeah, so sorry about that. So coming back to this, as mentioned, let's talk about how do you assign an IP address to any system. Okay. So usually to any device, there are two methods to assign an IP, guys. One is a manual method, which you can assign from the control panel. Two, you get it automatically from a DHCP server. Don't worry about DHCP, we'll talk about that in a bit. But first, let's try to understand how we can manually assign an IP to our system. Okay. So to assign it from the control panel, there's a certain procedure. Okay. First, you open up the control panel. In that, you go to network and internet settings. In that, you go to network and sharing center. And in that, again, you select change adapter settings. In that, you right click on the adapter, go to properties, and go to IPv4 properties and assign the following IP address. So this is the whole procedure to assign a manual IP on your system. So let's repeat this whole steps. First, go to control panel here. Yeah, control panel. In your control panel, open network and internet. In network and internet, go to network and sharing center. In network and sharing center, click change adapter settings. In adapter settings, select the adapter which you want to change the IP address for. Let's say we want to change it for my Wi-Fi adapter. Right click on that adapter, go to properties, click on IPv4 properties, and click on properties again. And you would notice there are two procedures. Either you get an IP automatically from a DHCP server, or you assign an IP of your choice. Okay. Right now, my system is getting the IP 192.168.0.5. But let's say I wanted to change this. Okay, so if I had to assign a new IP, I would type the new IP address here. Let's say 192.168.0.100. Okay. And subnet mask, this is a class C IP. So subnet mask is 255.255.255.0. Default gateway, that's your first IP in the network, router's IP, 192.168.0.1. So you assign these three pieces of information. And then there's one more extra piece of information to specify, which is called a DNS server. Don't worry what a DNS server is, guys. We'll talk about that in the next class in tomorrow's session. Okay. So again, if you don't know what to enter here, just go to your browser and simply search Google DNS server IP, and that will provide you two addresses. One is 8.8.8.8 and the other is 8.8.4.4, and you can use any one of them. So you can type 8.8.8.8 or alternative 8.8.4.4. Okay, even if you enter one of them, that is also fine. Chalega. Okay, so this is the piece. This is all the information you have to enter piece by piece in order to assign an IP address of your choice. So when I click on OK, And when I click on close, this will automatically now change my IP from 0.5 to 100. So since I'm changing my IP address, guys, we might get disconnected for a while. Don't worry, we'll automatically reconnect to the session as well. So let me click on. Right. I must have, I hope you can hear me now. So I just got reconnected. And now if I type ipconfig again, now you would notice this is my new IP. So find my Wi-Fi adapter. The new IP address is 192.168.0.100. So this is how you can manually assign an IP to your system. So again, this is what you had to do earlier in the olden days, guys. So when you didn't have something called a DHCP server, if you were the network administrator for your organization, you had to go to each and every system in the network and assign a manual IP this way. But today, we don't have to do this, all thanks to a DHCP server. In our networks, DHCP servers handle the job of assigning every device an IP address automatically. So they have taken up that responsibility. If you don't have a DHCP server in your network, you have to manually go and assign an IP to each system, a unique IP, and you have to keep a track of it, which device has what IP address. Okay. So to make your job easier, just with one single click, your device gets an IP from a DHCP server. All you have to do is go back to that same control panel, properties, IPv4 properties, and just select this one button, obtain an IP address automatically. And when you click on OK and close, that will assign an IP automatically from a DHCP server. So when I click on connection for a bit, I guess we are back in our connection. If I type ipconfig again, you can see I got my old IP address back, 192.168.0.5. But now the question is, what is this DHCP server? How are we getting this IP 192.168.0.5? Let's talk about that. So when you talk about DHCP, it stands for Dynamic Host Configuration Protocol. Okay, from the name itself, you can figure out actually it is used to dynamically or automatically configure an IP address to every host in the network. Okay, and that is done with something called a DORA process. Okay, so basically your DHCP server has a pool of IP addresses. So in our home network, our Wi-Fi router itself acts as a DHCP server. So it gets the first IP in the network, 192.168.0.1, and the remaining IPs are in a pool for it. It's a pool available list of free IPs which it can assign to every system connected in the network. And whenever there's a new device in the network, it assigns an IP from that pool with the help of something called DORA process. Okay, so let's talk about this DORA process now. So as you can see, whenever you are connecting any new device from this pool, each IP is being assigned to the system here with the DORA process. So let's talk about the DORA now. So let's assume there's a new device in my network and there's a DHCP server as well. So first things first, when this device is completely new and it doesn't have an IP, what it does is it starts broadcasting a signal, and that signal is called the discover signal. So no matter how many devices are there in the network, it sends a discover packet to every device in the network. Okay, and purpose of this discover packet is to figure out where the DHCP server is. So it's asking each and every system in the network, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? So when it reaches the wrong devices, that packet gets dropped anyways. But when it reaches the correct DHCP server, that server responds back with an offer saying, hi, you were looking for me. I am the DHCP server, and I've observed that you are new to this network, so I can offer you an IP address. So it offers an available IP from the pool. And when that offer is made to the client says, hey, thanks for reaching out to me. I request you to allocate that IP to me and assign it to me, and do not give it to anyone else. Okay. And for that request, again, your DHCP server acknowledges it. So it sends a final confirmation called acknowledgement. And with that acknowledgement, your device gets that IP assigned, 192.168.0.5. And all of this happens in like a snap. Okay, and within a few milliseconds itself, this whole process occurs. And I'm pretty sure you've observed this process at least once in your life. Okay. So if anyone of you has an Android phone, whenever you connect to a new Wi-Fi router and when you enter the password and click on connect, for a very short duration, you see this
It says
message
obtaining
obtaining,
IP.
obtaining IP address. So during that procedure, your phone is requesting for an IP address. It's performing the DORA process with the Wi-Fi router. Okay, so it sends a packet to the Wi-Fi router. It asks them, give me, if you have an IP, offer it to me. So your Wi-Fi router offers an IP, your client requests for again confirming that, and your Wi-Fi router acknowledges that or confirms the IP and assigns an IP address to you. So this whole process is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. Okay, is that clear, guys? Any questions or
Just
doubts?
one. I had two doubts. One is like this: as soon as I power on my Wi-Fi switch, then automatically my mobile will be sending discover message to all the uh, routers which are available in the room, right?
On you again, yeah, definitely. When your phone has that Wi-Fi option selected on it, when
Yeah.
it is powered on, yeah, then it starts automatically sending a discover packet to all the devices in the network.
Okay, and all will be sending me that offer, and out of that offer, I will be selecting one of. So normally it happens
Yes,
like that.
that's it. First
Okay.
come first serve.
Okay.
Whichever it receives the offer from first, it will carry forward the remaining request and acknowledgement with that DHCP server.
Okay. And second doubt is like in the previous when you did manual configuration of IP addresses, so
Mhm.
over there that you did for a particular adapter, right? If that suppose in my laptop there are two adapters and one goes down,
Mhm.
so that manual configuration will go off. It will take the second adapter's thing, right?
Right.
And
Again,
automatically the IP will be like a new IP will be generated for that.
definitely. Again, depending on if your second adapter is configured as well. If you're configuring it manually, it will use the other IP. If not, it will. If you've configured it automatically to retrieve from a
The
DHCP server,
automatic. Okay.
it uses the DHCP IP.
Got it. Clear.
Right. So again, let me just show you this DHCP server as well practically, guys. So as mentioned, in a home Wi-Fi router itself acts as a DHCP server. So if I have to connect to my router, I can just go to my browser and search here 192.168.0.1. This is my router's IP. Okay, so I'm using a TP-Link router at my home. Let me log in with my credentials. So again, if I go to my network settings here and LAN settings, you can see my Wi-Fi router, my TP-Link router itself is acting as a DHCP server. And this DHCP server is getting the first IP 0.1. And you can notice here, there's a pool from 0.2 to 199. So I'm not using the list of all IPs. I'm not going up to 254. I'm just going up to 199. Okay. And out of that pool, you can see each IP is being assigned to a new system here. Okay, one by one. And there's something called a lease time as well. So once an IP is assigned, it's not assigned forever, guys. Okay. There's a lease time, usually 24 hours. So after that 24 hours, if the device is still active, it gets the IP again. If the device is not active, that IP goes back to the DHCP server. Okay, so that it can be freed up and can be assigned to another device. So this is what a DHCP server practically might look like. Okay. So yeah, that's that, guys. Nothing further for our session today. We have gone through a few important concepts today, understanding what classes are, what is class A, B, C, D, and E, where do you use each class. Then we learned about subnet mask, then we learned about default gateway, then we learned about how to assign an IP address to your system, again, both manually and automatically from a DHCP server. So we learned what a DHCP server is and how does it assign an IP with the DORA process. Tomorrow, we're going to learn about the DNS server. So remember, I didn't discuss about DNS. I just mentioned two IPs, 8.8.8.8 or 8.8.4.4. But what are these IPs? What is a DNS server? So we'll talk about this in the session tomorrow. Okay, so we'll talk about DNS servers, we'll talk about special IPs, and that should conclude the whole networking part. Okay, and after that, on the last class on the weekend, we'll go with the practical session on how to install a lab setup. So yeah, that will conclude the demos for this week, guys. If you have not made any payment already, please do initiate a payment to the institute to continue the classes from Monday. Because from Monday, the link is going to change, okay, and it will not be the same link. Friday will be the last demo session. Okay, so yeah, that's that, guys. Nothing further.
I got a text from DurgaSoft with regards to this. So I told them like most probably later after first
Sure,
half
sure.
of this month, I think a new batch will be started. Then I will be connecting
No
to that
problem.
one. Then they
You
said
can
that
let.
update us with the. I mean they said that they up, me to update them, but uh, I wouldn't come to know about that. So I think hopefully in that Telegram chat
No
only it will
worries.
come like
Sure. Again,
uh,
just in case if you need any update regarding that, you can ping me as well. I've shared my
sure.
number already in the chat box earlier. But again, 9849984 Oh,
It's in that
what went up?
PDF, right?
That's a bit outdated, I guess. 1 second. Yeah, here's my number, Vivek, in the chat box. 984998477. Or you also have the DurgaSoft contact number in their official website. You can contact that number as well. So
I
again,
think I
just
might
drop.
have your number because I
Sure.
had very long
So
time.
just in case if you don't get any update on the Telegram channel or on your email, you can ping on this number or on DurgaSoft's mobile number, and they'll let you know regarding the next batch.
Okay,
But again, if
sure.
you're planning on joining at this batch, guys, the others, you can kind of make the payment to the institute and join at 7 p.m. time slot itself. Okay. So please discuss the details regarding the payment on all with the institute itself. And if they are not available, if you need anything, if you need me anything to forward to the institute, just drop a message on this number. Sure. Okay. So that's
Okay.
that, guys. Any questions before we end it?
I was just curious, like on your TP link, why did not it show like 255 available devices?
Which one?
On your TP link, it showed at the range of
199.
like yeah. So actually, it should be 255, right?
254. Again, I can modify this. So I didn't have the
Okay, you can
necessity for
modify
those
that.
many devices.
Okay,
Yeah. So this is
okay.
something
I
which I
thought like
can change if I want to. Okay, 199 or
yeah.
100 or 254. This is in my control. So I can modify it here. I can save the settings. Okay, so I don't have the necessity to connect more than 5 or 10 devices. So that is why I just put it at 199. That's all.
Got it. That
Okay,
last
you can
piece had to
modify
be
the
clear.
pool according to your choice.
Okay, thank you.
So that's that, guys. Nothing further. I'll exit the session now. I'll see you tomorrow at the same time. Bye bye.
Thank you
Good
for the
evening.
lecture. Bye bye.
Bye.